We will transform our function in the x values, and we can see that in our equation right here when we have our multiplier inside. Now this is the trickiest one of them all because it gets a little bit confusing, so we have to first get our function and then really look at how does it affect by a table, like really what's happening in the mathematics. So we have our parent function as 1/3 x minus 2, so our y-intercept is 0, -2, and we plotted that -2 as the y-intercept, and then we wrote down m equals the change in y over the change in x, which equals the 1/3, so we go in the right direction. So our change in y is 1 positive, so we went up 1, and then the change in x is a positive 3 going to the right. And then we continue that slope up 1 to the right 1, up 1 to the right 1, and make sure that we go through all the crosshairs, extending out past our graph with the arrows. Now, when we use our h function, actually this should be our h function, I just noticed, I'm going to put an extra column in the middle just to help us get what this f of 2x, the 2x that we will substitute in for f of x, because see, that's in the same place as that f of x. So once we get that number, we will substitute it in and then calculate our h of x. So I started with 0 because that's the easiest one to start with right now. 0 times 2 is 0, so we'll substitute 0 in for x up here in our parent function. 1/3 times 0 is 0, so that would be 0 minus 2 is a -2. So my coordinate pair is going to be 0, this one up front, 0, -2. Now I'm going to think about kind of what numbers will kind of help me in solving this. So if I started with 1 here for my x, 1 times 2 is 2. 2 times 1/3, that gives me a fraction, and I want kind of nicer numbers that I can plot to get my nice points on my graph, my crosshairs. So I'm thinking I'm going to start with 3, a power of 3. So 3 times 2 is 6, and once we substitute that in, 6 times 1/3 is 2. 2 minus 2 is 0. So my coordinate pairs are 0, -2, and 3, 0. My next one I'll probably do is 6. So 6 times 2 is 12. So that's my substitution number. I'll substitute. 1/3 of 12 is 4, minus 2 is 2. So now I kind of notice that I have some points that I can use, and I can substitute x is -3. I want to kind of do that. So -3 times 2 is -6. 1/3 of -6 is -2, and -2 minus 2 is a -4. And that follows my pattern of 3 change in, so a positive 3 for my x. So my change in x is positive 3, and my change in y here is a +2. So now I will go ahead and plot those. So 0, 2, -2, 3, so over 3 and up 0, over 6 and up 2. Huh. I would have thought that that would be a multiplied by 2. But that was that when it was 2 times f of x. That would be our y value multiplier. So that would change, that would affect the y values with the multiplier. So we're inside of with our x. So it's actually the shrinkage. And so it's kind of opposite. Well, it's not opposite because opposite is our negative number. It's our inverse. So this is an inverse of what's happening in the graph. So we are shrinkage. So it's a shrinkage of our x values by multiplier of 1/2. So it's that that inverse of times 2 is times 1/2. So now that I kind of have my slope of my points, I can go up 2 to the right 3, up 2 to the right 3, and get more points that are on my graph. So to the left 3, down 2. So if I take a look at my x values, I can see that this one is a 6. So half of that, the multiplier is 1/2 of that, because inside, even though it's a times 2, it's going to be our shrinkage of multiplier of 1/2. So if I go now to this one, which is 9, it's going to be 4.5. But I'm going to use my slope now that I have it. So down, or -2 for change in y, and +3, -2, +3. So I can get some nice points at the edge of my graph to make it much more accurate. Excellent. And add our arrows. So this is our function of f of 2. So if I move to now, what happens when we have, so k of x will be f of 1/2 x. So now inside here we have a times 1/2. So if I think about that inverse of that, because it's in the inside, different than if it was 1/2 times f of x, that would be our multiplier of our y values, a multiplier of 1/2, which would affect the up and down. This is the left and right, so it's the inverse of that. So our x values are times that inverse of 1/2 is a 2. Does that make sense? In that we want to multiply that. And so if we can make our table, if it's kind of confusing, we can make our table with our x's. And this time I think I will use something that will work with 3 and the 2. So I think I'll do 6's. Rather than the 3's, because I think I'll get fractions with those. So remember, it's going to be the in between what number I substitute in to my parent function to get k of x here. So I'll start with 0. 0 times 1/2 is 0. Then I substitute that in for x up here, and we get 0 minus -2, or -2 is -2. So when I substitute 6 in for 1/2 x, I'm going to calculate out of 3, so that means my 3 goes into my x up here in my parent function. 3 times 1/3 is 1. 1 minus 2 is a -1. I'll do the same thing for -6, so that would be a -3 as the substitution number in for x up here. So -1/3 times -3 is -1, minus 2 is a -3. So now I've got my slope, also +6 for my change in x, and my +1 for my change in y. So 0, -2, -6, 2, 4, 6, and down 1, 2, 3. So if I look at that, I have my y value, or my x value originally was -3, and that inverse of the multiplier of 2. So that inverse of 1/2, because it's inside with the x, is a multiplier of 2. So I'm going to use my slope up 1 and over 6. Or I can even think about that 3. X is 3, so x value is multiplied by 2. And we get a nice point, and that would be the closest I could get to my edge, because 6 more would go a little bit further. Just want to make sure I get right in the crosshairs of those. And this is our k of x. So remember, when the multiplier is outside, that is our y value. Like these up here are the y value multipliers, and they just are staying the same. So if it's times 2, it's our y values that are times 2, or times 1/2, or if it was a 1/3 up front, it would be the y values are multiplied by 1/3. When it's inside, like the 2x or the 1/2 x, or if, let's say, we make another one, L of x equals f of 1/3 x, that means my x values will be multiplied by 3/1. Or we could just call it a multiplier of 3, because of that inverse when it's inside. So it's that inverse of that operation, which is that multiplier of the reciprocal.